Okay, this lesson is about vectors on the Cartesian plane, the xy plane. Okay, so I can have a vector that's given by basically a set of coordinates, okay, or directions that they're going in. Vector A can be given by its x direction over its y direction. Also, it can be called like just A1, A2. And if I had vector B, it'd be B1 and B2, being its x direction and its y direction. Okay, so if this vector A, going from here to here, maybe it moved over 4 units and went up, let's say 3 units. So that would be, vector A would be then over 4, up 3. Okay, x movement, y movement. Okay, this is called the component form of a vector, when it's written like your x movement over your y movement. Take the vector, here's a new vector A, went over 3 and up 5. Over 3 and up 5 to get that vector A. Vector B has gone over 4 and down 3. So it would be over 4 and down 3. Vector B would look something like that. Okay? X movement over Y movement. Now, when it's in component form, I can do certain operations. Okay? I can figure out the negative vectors. So if I have vector B, which is 2, 5, the negative vector B would be negative 2, negative 5. It's going in the opposite direction on both the x's and the y's. Okay? I can multiply by some sort of scalar. So if I have vector B being 2, 5, vector 3b would be multiply my original vector B both by 3. So my x gets multiplied by 3 and my y gets multiplied by 3. Okay? It's scalar multiplication. Multiply both the x component and the y component by that scalar in front. If I have two different vectors that are written in component form, okay, I can add those vectors together. I don't need to draw them out and add them up. I can just simply add my x movements and add my y movements to figure out the resultant, which would have happened. So in this case, vector B plus C would be add your x's together, 2 plus 1, add my y's together, 5 plus 4, and it would equal 3, 9. That is the resultant vector, okay, of adding vector B plus vector C. I can go a little bit more complicated. I have B subtract 3C. Well, let's take vector B, which in this case was 2, 5, and I'm going to subtract 3 times vector C, which in this case was 1, 4. Now I can multiply this negative 3 in, okay, to vector C. So I'm going to have 2, 5, subtract 3, 12. And I can figure out the resultant by subtracting my x components and my y components. Negative 1, negative 7. So went back 1, down 7. Okay, the final resultant vector between the two of them. I can find the magnitude between the vectors. Magnitude being the speed. Now if I take vector 3, 4, it's gone over 3 and it's gone up 4. Now the magnitude is the length of the line, the length of the vector. Now if you look at this, this forms a right angle triangle when you go over 3 and you go up 4. And my magnitude, the length, is the length of that hypotenuse. Now hypotenuse of a triangle, a squared plus b squared equals c squared. 3 squared plus 4 squared equals c squared. I'm trying to find the hypotenuse. 9 plus 16 equals c squared. 25 equals c squared. 5 equals c. My length is 5 units. Now this formula could be, when you put it into vector form, is the magnitude of vector A, magnitude being given by the straight lines of vector A, is equal to, and this is just the Pythagorean theorem, haven't been rearranged and already taken the square root. So you have your x component squared, so I'd have equal to the square root. In this case, it'd be 3 squared plus, and then your y component, 4 squared, which could be the square root of 9 plus 16, square root of 25, which equals 5. Okay, and whatever your units might happen to be. Okay, so I can find the magnitude using the formula square root of your x component squared plus your y component squared. It comes from the Pythagorean theorem. For example, let's say I have two vectors, P and vector Q. And I want to find the magnitude, okay, of adding the addition of p plus 2q. So let's first find p plus 2q. So p plus 2q is going to equal vector p, which is 1, 4, plus 2 times vector q, which is negative 2 and 5. So I have 1, 4 plus negative 4, negative 10. Add them up. I'm going to get vector negative 3, and I'm going to have vector negative 6. Okay, when I add them up, this is vector p plus 2q. I took 2 times vector q, and I added vector p. Now I need to find the magnitude of that. So the magnitude of p plus 2q is going to equal the square root of the x component squared plus the y component squared, which will give me the square root of negative 3 squared is positive 9, plus negative 6 squared is 36. 9 plus 36 is 45. So my magnitude, the magnitude of p plus 2q, is the square root of 45 units. Okay, so the length of that vector is the square root of 45 units. Okay, so this is a quick little lesson on vectors in component form, where you have your x direction over your y direction, and you have all sorts of algebra you can simply do with that. Thank you very much.